talk about, up to this point we've been doing mostly just read only, right? So let's do some inserts, updates, deletes, and whatnot, right? So for instance, let's start with inserting something into the database. So for that, the user model exposes the generic create function, right? So instead of insert, right, at the command line you type insert. Here you type create, right? So let's do that. So in the data model, right? So let's declare here a create. So this will be create user, and it takes as argument a user object, and we're just going to save that, right? In JPA you would use save, repository.save. Here is create, so it's a user model dot create, and you take as argument the user object, and that user object is going to be verified against the schema. Okay. Make sure that the username is spelled correctly, that all the fields are correct, that the right data type and whatnot. And what it returns is the object that would actually insert it in the database. So it'll have an ID, right? We don't have an ID here when we pass it. So when we test it, we can say DAO dot create. Oh, we didn't export it, so let's do that. So create user, and we can pass as argument an object. So with username, username ed, and password ed, and first name Edward, and last name Scissorhands. So that's going to create the object, and it's going to return a promise, right? And that promise, we can just see what comes back, right? And so this is the actual user that was inserted, and then we can just print it out. Console log, the actual user. And the only difference is that the one we passed in didn't have a primary key, but the one that comes back does have a primary key. So that if we run that, and notice that there's the primary key that's right there. See that? Okay. All right. Awesome. Let's see. Let's now do some maybe some updates. There it is. So let's write it. And so in user DAO, we can create an update here. So update user, and that's going to be typically is going to take as argument the ID of the user that we want to update, and the actual user with the new values, right? Notice that it's two arguments, two parameters to the function. So in this case, we do need the extra 2 characters, and then we can use the user model to actually update, right? So the update function, and the update function takes 2 arguments, right? The first argument is which document do you want to update, right? The one that matches the user ID, right? So it's the one that has whose ID it matches my user ID, and then the second argument is what is it that you want to update, right? So here again, it's the same argument that you would pass if you do it at the command line, right? If you just put the fields, it's going to replace the fields, yes. Instead, typically what you want to do is use the set, right? So that you set those fields that you want to change, yes. So you could say I want to set, right? I want to set, and then whatever you want to set. Maybe you want to set the username to user.username. Maybe you want to set the username to username. Maybe you want to set the password to user.password, right? Etc. Right? And then you change all the fields. But guess what? Who has that structure already? The user already has that structure. Right? So there's no point in me just copying this over, right? So I could just say set user. Right? So the fields that match will be updated, right? And the one if there's a field that is missing, then it will not be updated. But if it's there, it will be re-updated, right? So that's going to set it. It's going to set it to its new values, right? And so let's try it out. So let's change the let's change here something. So let's change ed. Do we have the run? We know that ed's ID. There's the ID, and let's update it. We can say oops. We can say DAO dot Oh, I think I didn't expose it. So this is update user. So update user, the ID. That's the ID. And what we want to change is perhaps, maybe we just want to change the password, right? Because the password was a very bad choice. So let's change the password, right? And we'll say that we'll do change password to something more secure. Right. Notice that only the password will be modified because I'm only passing an object that has password, and that's the only field that will be modified. You see that? It's not going to replace the object, right? But only that field will modify, right? Whatever I pass here. Right? So if I run this again, right? Not quite sure if that worked. Never mind. We can always compare that. We can go fetch that user by ID. There it is. We can pass in that ID and run this, and notice that the password did not change. What? Is that the ID? It is, right? I'm sorry? Oh, I did not run it. I didn't say then. Right, if I don't do the then, this won't actually execute. Okay, it will not be resolved. It would not be executed. So this is a compiled that will not be actually executed until you run the then. Now the then, it's interesting because the then, you might expect here that you would get the new user as it has been updated. Actually, you don't get the user. What you get back is a status, right? Saying, was it successful? Was any record actually updated? How many records were updated? Maybe we updated a whole bunch of records, right? So you get back a status, and we're going to do a console, a log, a status. Okay, so run this. Okay, there it is. So one was modified, and if we find all, not all of them, just I think that's the ID, isn't it? Yeah. Indeed, it was changed. The password was changed. Everybody okay? Awesome. Deleting objects is as easy as you would expect, right? In the DAO. Here it would be something like delete user takes as argument the user ID, and you would use user model dot. I never forget if it's a remove or delete. So it's remove, and then you have the filter on which record do you want to remove, and we need to expose the delete here. And so let's remove Edward. So if we look at all the users, we see that we have Ada, Tim, John, Jane, and Ed. So let's remove Ed. Let's remove Ed. So we say DAO dot delete user. And the ID is this one over here, and then it's going to do a then, and the delete also returns a status, which we can then print out the console log status. Right, and we can run this, and it says, yep, one was deleted, and we can certainly. Oops. We can retrieve all the users and check to see that indeed it has been removed. Yes? right? Okay, what if, notice that I was first removing and then checking to see if it was all removed, yes? Or I was inserting and then checking to see if they're, checking all of them are there. Or maybe I then updated and then checking to see if they're all there. What if I wanted to string together multiple things, right? Maybe I want to create, then I want to update, and I want to delete, and I wanted to execute in a sequence. Now, say I want to do the a retrieval of all, DAO.findAll, find all, right, and then users console log users, right? Certainly that works, right? If we run that, there they are, right? So there's 1, 2, 3, 4. Yes. But what if after this completes, I want to add a new user, and after it adds it, I want to display it again, right? So one naive way of doing it would be to do the DAO find all, then create a new user. Let's see, the user's username, and this is Charlie. Let's just use the username. That's it. And then here's the new user that was just created. Right, and then I want to display them again afterwards. Okay, let's do a console here. Console log 1, 2, and 3. Right. Also, another thing that might be of use here is that I'm going to put this in an actual function like that, and we're doing a console here. We're going to console. So this is 1, 1, and this is 2, 2, and this is 3, 3. Okay, all right. So if we run that, the expectation would be that I would see all the users, and then I would see maybe an additional user, right? And maybe we'll get lucky, and that's what we'll see, right? But the point I'm trying to make is that it's not guaranteed, right? It's not guaranteed that that's actually going to happen. So if we run this, notice that we have 1, 2, 3, 1, 1, 3, 3, and then 2, 2. Notice that the insert occurred after, right, the actual retrieval. And notice that in the first case we have 4, and the second one we still have 4. What happened to Charlie? Right, notice that it was inserted after both of the two, after both of the two queries of retrieving them all completed before the insertion. Right, insertion is much more expensive, right, than retrieval, than reading, right? And as I mentioned earlier, these are not executed synchronously, right? Meaning, I don't block here waiting for this to complete before I continue on to the next one, right? Before I continue to the next one. So there's no guarantee in the order in which these things execute. Make sense? All right, that's the whole point of them being asynchronous. But oftentimes we do need to make things synchronous, right? We need to force things to execute in a particular order. So how do we do that, right? So the way to do that is the following. Say I wanted this to execute in order. One way to do this is to put this right here, right, inside of the then. Now I know that this 2 will execute only after 1 completes, right? Because it executes after the then. What about this 3 over here? I want this to execute last. Right, so again, the only way to guarantee this is to put it inside of this then. Right? Notice how ugly this code is starting to look. Right? Where you have all this embedded, right, code that goes one inside of another. Right? And when you have a lot of these asynchronous chains, right? Where you have to synchronize and you have to make sure that things occur in a particular sequence, you're going to end up with all these very deep chains of things that are very hard to read, right? So that's exactly why the then API and these promises was created, to avoid exactly this, right? So before we do that, let's verify that this actually works, that it actually executes in the order that we are claiming that it executes. Notice that we have 1, 1. We have 2, 2 inserting. I guess we inserted add twice. And then you have here the last one where you have, oh, I'm sorry, not add, Charlie. And here's Charlie inserted twice. You see that, notice that we did guarantee the sequence of execution, right? Which is exactly what we wanted to do, but at the expense of making our code really ugly. All right, so how do we deal with this? How do we deal with this ugliness? So what we can do here is that, what we're going to do here is the following. Here's this DAO here. Right, here's the DAO. And here's the then here. Where's the then complete? The then finishes where? Right here. This is where the then completes. Yes? Right. What we're going to do is the following. This create user, right? Instead of having this then right here, okay, we're going to return. So what does that return? It returns the promise. Yes? Right? So meaning that at the end of this then, what does this then return? It returns this promise. Make sense? That means that this then, right, which goes all the way to here, right? This then, we can cut it out. Right? We can cut it out, and we can put it at the end of this then over here. Okay, and we can put it right there. Right. Let's fix the formatting here a little bit. There it is. Okay, notice that having returned this allows me to put the then instead of here, moving it down here. Yes? And it almost looks like I'm first going to do this, then I am going to do this, right? In sequence, in that order, right? It almost looks like it's synchronous. It almost looks like it's not asynchronous, even though, right, it is, right? And then internally, we can do the same thing with this finder here, right? We can do the same thing with this finder. This DAO could then do the same thing. It could return, right? And what we can do now is move this then out of here and just put it down here. Okay? Right? So syntactically, this is identical to what we just had. Right? I'm sorry, functionally. Functionally is identical to what we just had. Syntactically, it's so much easier to read, understanding that this looks more like this occurs first, this occurs later, and this occurs last. Right? It's not these endlessly embedded internally inside, right? But it allows you to write it in such a way that looks as if they are executing sequentially, which they're not. Yes? Yes. Yes. Right, you would have to have a catch. Yeah. Yeah, you would need a catch down at the bottom to catch all these errors. You can have one for each, right? Or the then takes two arguments. The then takes two arguments. The first one is the function, which is the success, if it's a resolve. Right? The second argument is a function that gets called if there's an error, if there's an abort. Okay? Which we're not using here. So this function here, this is the success function. Right? And you can do a comma, and you can say an error, right? And then handle the error here. So the second argument is the error handler. Right? Yes. Or you can use a catch as well. Yes.
But what if I don't have something to return a promise to the outer one? For example, if I just on the second line, I just want to print out something in the console, but I don't actually want to find more users.
Right. This is only to the extent that these are all asynchronous calls, right? That they are all using the promise API, right? If there is no promise, then this makes no sense, right? To break it up into asynchronous calls, you would just use normal synchronous calls, yeah. But sometimes you need to wrap things into a promise, even if it's not a promise, and you could say new promise and wrap that object in a promise and return that instead. Yep. So if we run this again, right, instead of Charlie, maybe we'd say Bob. We run that. Notice that first we had the two Charlies. We inserted Bob, and then at the bottom, then we just have Bob. See that? So it executed as if it looks like it's sequential, the code, right? You just need to do that extra work, right, of remembering that these are promises, and then you can return, and then you can use this kind of syntax, which makes it much easier to read. Yes? All right. And deleting objects. All right, many.